a novel methodology for human kinematics motion detection based on smartphone sensor data using artificial intelligence. Welcome to Journal Club. The latest academic research, explained in plain English. Today we're looking at this paper from MDPI's Journal of Technologies. It's authored by Rasa et al. From the Khwaja Farid University of Engineering and Information Technology in Pakistan, and is published open access under a CC BY license. Let's start by translating the title into more accessible language. When you read this title, you can understand it to mean in very simple terms that this paper explains how smartphones can be used to track and analyze human movements using artificial intelligence. Let's expand on that a little. The paper describes a new way to detect how people move using data from sensors in their smartphones. They use something called artificial intelligence to analyze the data and figure out what kind of motion the person is doing. It's a fancy way of tracking how people move using their phones. Now we understand the title, which is a good start, but before we can break down the full paper, we'll need to catch up on some terminology, jargon, background information and context. Specifically, there are some key concepts you'll need to be familiar with. Let's define them now. Kinematics motion detection. The process of identifying a person's movements based on activity data. Artificial intelligence. The ability of machines or computers to learn and make decisions like humans. Smartphone sensor data, information collected by sensors in smartphones, such as the accelerometer and gyroscope. Computer vision, the ability of computers to interpret visual data from images or videos. Hyperparameters, settings in machine learning algorithms that impact their performance. Ensemble learning, a technique in machine learning that combines multiple models to improve accuracy. Random forest, a machine learning algorithm that creates multiple decision trees to make predictions. Decision tree, a diagram that represents a sequence of decisions or rules and their possible consequences. Classification accuracy score, a measure of how accurately a machine learning algorithm can classify data into specific categories or classes. K-fold cross-validation, a technique in machine learning that tests a model's performance on multiple subsets of the data to reduce overfitting. Now that we understand the title and key concepts, we're ready to dive in and break down this paper. In this presentation, we're going to attempt to answer 5 questions. 1. What were the researchers trying to figure out? Or more specifically, what was their hypothesis? 2. How did they conduct their experiment? That is, how did they test their hypothesis? 3. What were the results of the experiment? 4. What conclusions did the authors draw from those results? And lastly, 5. Why does this research matter? Why should you care? 1. What were the researchers trying to figure out? The researchers hypothesized that it is possible to use smartphone sensor data to accurately detect human kinematic motion such as walking or running using artificial intelligence techniques, and that their proposed ERD, ensemble random forest decision tree, method would outperform other existing methods. 2. How did they conduct their experiment? The researchers used a publicly available smartphone sensors dataset from Kaggle, called data collection, which recorded and labeled walking and running activities using the accelerometer and gyroscope sensors on smartphones. They conducted exploratory data analysis, including data balancing analysis, correlation analysis, and three-dimensional space analysis, to determine the relevance and separability of dataset features. The dataset was split into training and testing portions, with a ratio of 80-20. Machine learning and deep learning methods were applied and hyperparameters were tuned to achieve high accuracy. The researchers proposed a novel ensemble learning-based ERD method, which combined random forest and decision tree models to detect human motion kinematics as walking or running. Voting was performed between the two models to determine the final output. The proposed ensemble method achieved high accuracy performance for the classification of human motion. 3. What were the results? The researchers developed a methodology for detecting human motion using smartphone sensor data and artificial intelligence. They experimented with machine learning and deep learning techniques using different frameworks and found that the ensemble learning-based ERD method outperformed the others, achieving 99% accuracy, precision, and F1 scores for detecting walking or running. They also conducted K-fold cross-validation and confusion matrix exploration to validate their approach. The proposed approach has less runtime computational complexity and outperformed other state-of-the-art studies. 4. What conclusions did the authors draw from their results? Overall, the results show the effectiveness of the proposed method compared to traditional methods. The researchers suggest that this approach could revolutionize how we use mobile devices in the future. The proposed methodology could be further improved by incorporating more advanced machine learning algorithms and testing on a larger dataset. 5. Why does this research matter? The research paper proposes a novel methodology for human kinematics motion detection based on smartphone sensor data using artificial intelligence. The methodology has many valuable applications in healthcare, such as health monitoring, preventing obesity, virtual reality, daily life monitoring, assisting workers during industry manufacturing, and caring for the elderly. The implementation of machine learning on a smartphone, smartwatch, or even embedded microprocessor has the potential to revolutionize how we interact with these devices. The proposed methodology allows for accurately detecting and classifying various human motions, and could be further improved in future works by incorporating more advanced machine learning algorithms and data from additional sensors such as depth sensors or cameras. We hope you've enjoyed this Journal Club presentation of a novel methodology for human kinematics motion detection based on smartphone sensor data using artificial intelligence. If you'd like to read the full paper yourself, which we encourage you to do, you can find it at DOI 10.3390/technologies 11020055.